Okay, so let's continue on with this video. I mentioned that we have a wind going to the west at 2 meters per second, but because it's going to the west, or it's going the opposite direction, this should actually be negative 2 meters per second, because vectors have a direction. Okay, so to solve this problem, what we need to do is we need to add all the x components of the vector and all the y components. So I'm going to write over here the sum of all the x components and the sum of all the y components of a vector. Alright, so let's see. Remember from over here, the original vector has an x component of 4.33 meters per second going to the right, so it's positive. I'm going to write that here, 4.33 meters per second going to the right. And then let's take a look at the wind. The wind is going 2 meters per second to the left. So instead of adding, we're going to subtract. We're going to say minus 2 meters per second. It's minus because it's going in the opposite direction. So we have 0.33 minus 2, that's 2.3. 2.33 meters per second. Okay, in the x direction. And in the y direction, we said the vector, the sailboat in the y direction goes 2.5 meters per second. So 2.5 meters per second. Let's take a look at the wind. Does the wind have any y components, anything going in the y, in the up and down? It doesn't have anything going in the up and down, so it doesn't have a y component. So right now we found the x component, the sum of the x component, and we found the sum of all the y components. Once you find the sum of all the x's and the sum of all the y's, you need to create a totally new graph with this piece of information. Okay, so I'm going to draw a vector now, and we're going to say the vector is going 2.33 meters per second this way. So this vector, okay, so this way, this is 2.33 meters per second. And then in the y direction, we said it was 2.5 meters per second. So I need to draw a vector going in the y direction, 2.5 meters per second. Okay, notice that I have the head of the blue vector connected to the tail of the pink vector. And what we need to find now is the resultant vector. So where's the boat actually going to be? The boat is actually going to travel this way. That's what we need to figure out, because now we have the legs of the triangle, the two legs. We need to figure out the resultant, or the hypotenuse. R for resultant. We need to find out the hypotenuse, or the resultant of this right triangle, and this is where the Pythagorean theorem comes in to find the resultant. Okay, so I'm going to write the Pythagorean theorem is a squared plus b squared is equal to c squared. A is going to be 2.33 meters per second squared, meters per second, I'm sorry, plus 2.5 meters per second squared is equal to c squared. Okay, so we're going to have 2.33 squared plus 2.5 squared. That's 11.67. I'm going to round to 11.68. So this is going to be 11.68 meters per second. And to find c, you need to take the square root of that. So the square root of 11.68 meters per second is equal to c. Alright, so let's do the square root. 11.68 is let's round to 3.42. So 3.42 meters per second is equal to C. This is telling you how fast the sailboat is traveling with the wind. Or remember that originally the sailboat was traveling at 5 meters per second, but the wind is slowing it down. So in reality, the boat, although it wants to travel at 5 meters per second, the wind slows it down to 3.42 meters per second. Alright, so now that we found that, again, remember that vectors, it's not just the magnitude, it's also the direction of the vector. So we need to find this angle theta, the direction of the vector. So where is this boat located? And to do that, we're going to use tangent. We know that tangent of theta is equal to opposite over adjacent, or like I said before, opposite is going to be the y over the x. So tangent of theta is equal to the y component over the x component. So we know that the y is 2.5, so I'm going to put 2.5, and we know that the x is 2.33, so I'm going to write 2.33 here. So now to find the angle, we say theta is equal to the tangent inverse, or to the arctangent of 2.5 over 2.33. Theta is equal to, alright, let's go to the arctangent. 2.5 divided by 2.33, and we get 47 degrees. So 47 degrees is the new direction of this vector. So what have we found out? We found out that the boat was first traveling at 5 meters per second, but because of the wind it slowed down a little bit, so the new velocity of the boat is 3.42 meters per second, and it's traveling at 47 degrees above the horizontal, or 47 degrees north of east. Alright, so this concludes the vectors example for this problem. I'm probably going to be doing more examples on this, so stay tuned.